Okay, so it tells us we're going to use matrices to solve the systems, and we want to use Gaussian elimination with back substitution. So the first thing we need to do is we need to write our augmented matrix. So I'm going to come down here below it, and let's see my augmented matrix. Going to have three rows, and we write our coefficients. So 2, 1, 2, and then I got this line. It just, to me, it's kind of like my equal line because what it's equal to is on the other side. And then 1, negative 1, 2, and 9. 1, 2, negative 1, and 6. And guys, be really, really careful on your numbers and the signs in front of them. I don't know how many times I worked a couple of these problems when I was just going through it, and it was sign errors. So be really, really careful. That's the easiest thing to do is make a sign error here. Okay, so once you set up your augmented matrix, remember we're using Gaussian elimination. So this is where I need the ones in that diagonal and zeros for underneath it. So the first thing I need to do is I need to get a 1 in this first row, first column. Well, if I look at maybe the row below it, I notice it's got a 1 in the beginning. So I could just switch them. So the first thing I'm going to do then is I am going to switch row 1 and row 2. That'll put that 1 that I need at the beginning. So when I do that, let me set up here. I'm not going to touch row 3, so I'm going to go ahead and write it down. And I'm going to switch row 1 and row 2. So I'm going to bring row 2 up. So I'm going to put its numbers here. And I'm going to bring row 1 down to row 2. So I'm going to put those numbers. Uh-oh. Yep, I made a mistake there. So I said it's really careful. You got to be really careful on this. So this should be a 9. And this is my 18. Okay, so I went ahead and I went back here and I numbered what I did first and second. So first I set up the augmented matrix. Second, I went ahead and got a 1 for that first row, first column there. Now, the next thing I'm going to do is I'm going to look for the 0 that goes below it. So I need a 0 to go in that spot. So I'm going to come up here and do my next part. So if I need a 0 there, what can I do to row 1 that I can add or subtract or do something then with row 2 that would make that a 0? Well, if row 1 was a negative 2, then I could just add them together. So let's make row 1 a negative 2. So I'm going to take negative 2 times row 1, and then I'm going to add row 2 to that, and that's going to give me the numbers I'm going to put in row 2. I don't know why I wrote that below that. Let me write it beside it. Save a little room there. Alright, so I'm going to go ahead and start building another matrix here. Now, I'm not going to mess with row 1 or row 3. I'm only replacing row 2. So I'm going to go ahead and copy over my row 1 and my row 3 from my previous step. Again, watch out for those negatives and stuff. Don't let them catch you there. Alright. Now this is what we did in one of the previous examples. We took a number times row 1, I don't remember exactly which rows it was, and then added like a row 2 to it to replace it. So I'm going to take negative 2 times the number that's in row 1, which for the first column is 1, and I'm going to add the number that was originally there in row 2, which is 2. And remember, my goal was for that to be a 0, so it better be 0 or I've made a mistake and I need to go back and rework my formula so that it will become a 0. So I got negative 2 plus 2, which is 0. Alright, for the next column there, it's the same thing. So it's negative 2 times the number that's in row 1 plus the number that was originally in row 2, which is a 1. And so we got 2 plus 1, which is 3. So we're going to put a 3 there. And then for my third column, I'm going to take the negative 2 times the number that's in row 1 plus the number that was originally in row 2, which is 2. So I get negative 4 plus 2, which is negative 2. And then finally that last, that last column there, again it's negative 2 times the number in row 1 plus the number that was originally there, which is 18, and we get negative 18 plus 18, which is 0. Alright, so now we've got that 0 there. So I'm going to change colors here. So next, what do we need? Well, next we need a 0 below the 0 we just found there. So I need a 0 there. So how can I use row 1 or row 2 to help me get a 0 in that spot? Well, I can't do anything to row 2 that's going to make that a 0, because in row 2, column 1, there's a 0 there. So I'm going to have to use row 1. But if row 1, if that first number there had been a -1, then when I add that 1 in row 3, it's going to make it 0. So let's do this. Let's do negative row 1, and let's add row 3 to it and see what that gives us for row 3. So since we're doing that, we're not going to mess with row 1 or row 2, so I'm just going to recopy them. Alright, I'm either going to have to write really, really small here, or I may end up having to use some space on the side there. Alright, oops. So we said it's negative R1. So it's going to be a negative, or negative 1 times R1 if you want to. The number that was in R1, which is 1, plus the number that was originally in R3, which is 1. So negative 1 plus 1 is 0. And yay, that's what we wanted, remember? So then, same thing with column 2. So it's going to be negative the number that's in row 1, so negative 1. So negative 1, plus the number that was originally in row 3, which is a 2. So negative is positive 1, plus 2 is 3. So that's the number I'm going to put in that second column. And then we're going to do the same thing for the third column. So it's negative the number that is in that column in row 1, so a 2, plus the number that was originally in that column in row 3, which is negative 1. So we get negative 2 minus 1, so we get negative 3. And I ran out of room down at the bottom, so I'm going to have to write up above it just a little bit here. So for the last column there, it's negative the number we have in row 1, plus the number originally in that column in row 3. So negative 9 plus 6, which is negative 3. Okay, so now we got a 1 with the 2 zeros underneath it. Now my next thing is I need to make this 3 here become a 1. Now if we take 3 and we divide it by 3, it's going to be 1. But remember, what you do to one number in the row, you have to do to all of them. And that's going to end up giving me a fraction right there. And we want to avoid that if possible. So, but I do notice that row 2 and row 3 have the same number there. And if I took row 3 and I divided them all by 3 or multiplied by 1/3, I would end up with all whole numbers. So I'm going to go ahead for my next step. I'm going to switch my row 2 and my row 3 so I don't have to deal with fractions. So I'm just going to switch row 2 and row 3. So I'm going to go through and rewrite row 1 because I'm not messing with it. And it's what, 1, negative 1, 2, 9. I don't know why I cut that short there. I just wasn't paying attention when I drew it. Okay, and we're switching row 2 and 3. So I'm going to bring row 3 up. Now it's probably because I can't count now. So I was at 3. Sorry about that. Alright, so I'm going to bring row 3 up. So that's 0, 3, negative 3, and negative 3. And I'm going to bring row 2 down to row 3. So 0, 3, negative 2, and 0. Okay, so now that I did that, I am going to work on making that become a 1. And so if I take and I divide all those by 3, which means I multiply by 1/3, that's going to make that number become a 1. So I'm going to do 1/3 times row 2 to give me row 2. So row 1 and row 3 are going to stay the same. And just like before, I'm just going to go ahead and rewrite them. Let me move that over just a little bit. So I'm trying to keep them lined up. And I'm going to multiply every number in row 2 by 1/3. Well, 0 times 1/3 is 0. 3 times 1/3 is 1. Negative 3 times 1/3 is negative 1, and negative 3 times 1/3 is negative 1. Okay, guys, so now that we've got this, and I know this is really long recording, guys, and I'm really, really sorry. Just hang in there, okay? I'm trying to take my time so that you understand it, but yet I'm trying not to waste a whole lot of time. So we've got the one at the top in the top left, and we got zeros below it. We got the one in the middle there. So I need to make that number below the one we just found become a 0 itself. What can I do to that 3 that could make it become a 0 using one of the other columns? Now we can't just say we could subtract 3, because if I subtract 3, then that number's not going to work out. That number's going to become a negative 3, and then we're in trouble again there. So I need to use one of my other rows to help me here. But notice that first row has a 1 over there. So anything I do to it is going to put a 1 in the beginning there where my 0 is. And we don't want that either. So we've got to use row 2. So I notice in row 2, it's a positive 1 right above my 3 that I'm trying to get rid of. If I make that into a negative 3, when I add them together, that's going to put me a 0 there. So that's what I'm going to do for for my next step here, is I'm going to take negative 3 times row 2, and I'm going to add row 3, and I'm going to put that in row 3. Alright, so I'm not messing with row 1 or 2, so I'm just going to recopy them again. So that's what? 1, negative 1, 2, and 9. 0, 1, negative 1, negative 1. And then I need to work on row 3 here. So it's negative 3. For my first number there, it's negative 3 times the number in row 2, which is 0, plus the number we have originally in row 3, which is 0. So I get 0 plus 0, which is 0. And that's good. We didn't want that to change. We needed it to stay a 0 because that's one we already worked to find. Okay, then for the second column there, it's negative 3 times the number in row 2, so 1, plus the number originally in row 3, which is 3. So we get negative 3 plus 3, which is 0. And that's good because that's what we wanted. So then we work on the third column there. And again, it's negative 3 times the number in row 1. I'm sorry, row 2, not row 1. Be careful. Plus the number that was originally in row 3, which was negative 2. So you get 3 minus 2, which is 1. And that's even better because I needed a 1 there for my diagonal anyway. So now I'm not actually going to have to work that. If I didn't get that, then I would have to work to get it again. And then the last column there, it's going to be, again, negative 3 times the number in row 2, plus the number that was originally there in row 3, which was a 0. So we get 3 plus 0, which is 3. Alright, so good. Now we've got our 1s in our diagonal, we've got our 0s underneath, we are ready to start working the final piece of this. Thank goodness, right? Alright, so what we have here then is in this column, remember, this row, remember these columns, these were my coefficients of my x, these started out as coefficients of my y's, these were the coefficients of my z's, and these were the coefficients of the number that it was equal to on the other side of the equal sign. So what that first one is telling me is I put the arrow on there, the first row down at the bottom, says I have no x's, no y's, but I have 1z is equal to 3. As I go up then, I can see that the next row up tells me I have no x's, but then I've got 1y minus 1z equals a negative 1. And then finally in the first row up at the very top there, I see it says I've got x minus 1y plus 2z, and that's equal to 9. So we're just going to work our way backwards here. Since we know z is 3, we're going to plug that in to the next equation to solve for my y. So y minus 3 is negative 1, which means y is positive 2. And then we take both of these answers and we plug them into this one to get our x. So we know that x minus y, which is 2, plus 2 times z, which is 3, has equal 9. So just work that out algebraically. So x minus 2 plus 6 equals 9. So x plus 4 equals 9. Subtract the 4 and we get x is 5. Yay! So we got our solution set now. So our solution, dun, 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 for this problem is x is 5, y is 2, and z is 3. It's like an ordered pair. It's actually called an ordered triple. So you put all 3 in parentheses. And then, from what I'm seeing, they like to write it as a solution set. So they're putting it in the set notation. As I know, it's a long video. Thanks for holding on. Hopefully, you've got this. If not, I've got some more examples coming up, and we'll do a little bit more.